week is going to be stuff that you've seen before. But soon we're going to be transitioning to stuff that you've never seen with trigonometry before. So just as that heads up. Today we're doing an intro section. Stuff that in theory you need to know how to do in order to do the stuff that's actually in chapter 12. Simplifying radicals and Pythagorean theorem. First off, does anyone remember what a radical is? More of a guess than anyone else has given me.
I actually know what's wrong.
You know it's wrong. Okay. If you say so. That's radical. More commonly, you would call that what? A square root. Now, in all technicality, radicals are more than just square roots. It's any sort of root. So, cubic root, 13th root, 487th root. Those are all radicals. We are not needing the more complex radicals in here. When we're talking about simplifying radicals in this class, really we're simplifying square roots. Now, oftentimes when people think simplifying a square root, such as the square root of 72, their first instinct is go to the calculator, type in square root of 72, and give me the answer being 8 point something. No, that's evaluating a square root. Evaluating means give it to me as whatever number it is. Simplify means get it down to its simplest form. And a simplest form is not a decimal. Because if you're going to write out a radical as a decimal, you're going to have to round. I don't want a rounded answer. Simplified is exact. So, if I want to simplify a radical, really it comes down to knowing my perfect, well, since this time it's square roots, my perfect squares. So, before I dive into anything else, let's just make sure we're solid on those. Some of y'all know your perfect squares beautifully. Some of y'all are like, can tell me the first how many of them, and then you trail off and you're like, I don't know anymore. What's the smallest perfect square? Neither 2 nor 4 is correct. 1. Neither 2 nor 4 is correct. Okay, 1 is the smallest perfect square. It is 1 squared. That's what makes something a perfect square. It's an integer squared. What's 2 squared? It's 2 squared. Not what's 2. 2 is obviously 2. What's 2 squared? 4. Not 48. Y'all are scaring me. What's 3 squared? 9. 4 squared. 5 squared. 25, I heard it. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 100. 11 squared. 121. 12 squared. 13 squared. 169. Generally speaking, you only need it up to 12 squared. How many perfect squares are there? 12. Try again. A lot. Bigger. Infinite. There's an infinite number of them. So, generally speaking, we need the first 12, and more actuality, 1 is not helpful to us in simplifying radicals. Because if you want to simplify a radical, you have to ask yourself what is the biggest perfect square that divides out of the radicand, which is the thing inside the square root. What's the biggest one of these that divides out of 72? 36. If you do not know the answer to that, you grab a calculator. You say, okay, 72, smaller than 72 is 64, and you start dividing. In fact, I'll even give you a bigger hint and say, it has to be smaller than half that number, half that number or smaller at least. So you could even jump down and check if it divides by 36 and go from there. Either way, just go bigger, start with the bigger one and go smaller. Okay, specifically it is 36 times what to get 72? 36 times 2. So essentially what we're going to do is we're going to recognize what perfect square divides out of it, and it's that perfect square times what. Because with square roots, you can break them up if things are getting multiplied inside of them into 2 different square roots. One of each of the things being multiplied, or if there's more things being multiplied, break it up into more square roots. Simplify the one that's the perfect square. 36 was the perfect square, and the square root of 36 is 6. We get 6 square root of 2. Now, when you do this, there are a couple of common mistakes that I see happening. One common mistake that I see happening is people getting to this point, the square root of 36, square root of 2, and dropping the square root on the smaller of the two numbers and calling it 2 square roots of 36. No. Turn off phone or whatever is making noise. We don't need football sounds, whatever that is. Okay. So be careful. Make sure you only drop a square root symbol when you actually take in the square root. We took the square root of 36. That's why the square root symbol went away. Another common issue that I see is people don't get the biggest perfect square. Many of you would have looked at 72 and seen a different perfect square that divides out of it because it's a common multiple that we come across. How many of you would have immediately known it divided by 9 instead? And if you do that, it is okay. If you had recognized it as 9 and 8 getting multiplied together, you can do it that way. You're just going to have to do a little bit more work. Square root of 9 is 3. I get 3 square roots of 8. After you've done this, to know if you've got the biggest perfect square or not, look at the stuff inside the square root and see if it divides by a perfect square again, other than 1. Does 8 divide by a perfect square? Yes, it divides by 4. And if that is the case, you don't have to undo what you did, just go back and do it again. 8 is 4 times 2, which ends up being square root of 4 is 2. And keep in mind that these are getting multiplied. I ended up with 6 square roots of 2 again. Do you have to do it both ways? Absolutely not. I show you both because the easiest way is getting the biggest perfect square. If you don't get the biggest perfect square, it doesn't mean you can't keep going though. And sometimes with big numbers, recognizing a perfect square that comes out of it might be easier. For some situations, that is going to be significantly easier. For example, and I'm not going to actually do it on the paper, if I had asked you for the square root of 27,000, that's an awfully big number to be checking square roots on. But if you recognize, oh, well, it divides by 100, now you've made numbers a lot easier to work with. So, sometimes doing it the second way is going to be easier, but it's shorter if you find the biggest perfect square in the first place. Okay. Next example, square root of 50. I'm going to my name cards. The set. 50 divides by what perfect square? 25. Specifically 25 times what? 2. Okay, square root of 50, square root of 25, square root of 2. Sean, how do I simplify that down then?
Equals, equals 5.
5 squared is 2. If you can simplify it further, the stuff inside the square root will divide by a perfect square again. Just do 2 divide by any perfect squares. No, at least not other than 1, and 1's not a helpful one. So, always keep an eye on that, but sometimes it's going to be real easy, obvious numbers. Do one more like this, and then I'm going to change it up on you. Square root of 48. Emily, what perfect square does 48 divide by? Specifically 16 times 3. Spencer, if I simplify that down, then what do I get? 4 then 3?
Oh, like 4. Square root of 3.
There we go. Did I know that you probably meant that? Yes. Am I going to be picky? Yeah. Okay. So far this looking familiar? Something you've done before? Sometimes it's not just going to be a nice number inside the square root. Sometimes it'll be a fraction. Thoughts on how we can take the square root of a fraction? Yes. A square root technically is an exponent. When you have an exponent on a fraction, you put that exponent on the top of the fraction, you put the exponent on the bottom of the fraction. So the square root of 25 halves is the square root of 25 over the square root of 2. Now, I will tell you right now, if the fraction simplifies, you're better off doing that first. Did 25 halves simplify? No. Okay. Hudson, what do you think I'm going to do next? Square root of 25. I get a 5 on top over square root of 2. Here's the thing, you cannot leave square roots in denominators. Radicals are not allowed to be left in denominators. So we gotta do something known as rationalizing the denominator, where you get the denominator to be a nice integer. Specifically, a whole number, because we want it to be positive. Okay? So I need to get a square root out of the bottom. Thoughts on how to do that? So close. Multiply by the square root of 2. Generally speaking, if you want to get rid of a squared, what do you do to it? If you want to get rid of a square root, you square it. But we can't simply square the fraction, because if we square the fraction, we're changing the fraction. But we can essentially work with that idea. If I want to essentially, quote unquote, square the denominator without changing the fraction, I multiply it by itself. I multiply with the square root of 2 on both top and bottom. 5 times the square root of 2. That is outside of a square root. That is inside of a square root. They do not multiply nicely. They just kind of hang out next to one another, kind of like numbers and x's. It is 5 times the square root of 2 over. Square roots do multiply together. Square root of 2 times square root of 2 is square root of 4, which is now a perfect square. Square root of 4 is 2. So I get 5 square roots of 2 over 2. Technically, I have to check if that's it. I have to check a couple things to determine if that's my final answer. First off, I see there's a square root involved. The number inside the square root, does it divide by any perfect squares other than 1? No. If this simplified, if this square root was a square root of 48 or a square root of 50 or a square root of 72, I would have to do all this work to get there. It's not. It's a square root of 2. Secondly, do you notice there's no addition or subtraction in that fraction? Because that's going to make a difference to how we deal with this next piece. When there's no addition or subtraction in the fraction, like this one, simplify the whole numbers. Does 5 over 2 simplify? No. And do not tell me that it is 2.5. That is not simplifying, that is dividing. Simplify, as in simplify a fraction. Not give me a decimal. Decimals and square roots don't generally go well together. There's a time and a place, not here. Over square root of 20. Remember earlier when I said if you could simplify the fraction, you should? Can I simplify this, though? No, one's in a square root, one's not. They do not simplify together. Whole numbers simplify with whole numbers, square roots with square roots. Don't mix them. So, I want to simplify this. I got a couple of options on where to start. Xavier, thoughts on where to start?
Go over your simplify.
All I heard was mumbling.
Yeah. Square root of the bottom.
Simplify the square root of 20, in other words?
Yeah.
Okay, perfect. Austin, what am I going to do to simplify the square root of 20? Square root of 5 and square root of 4. Square root of 5, square root of 4. Grace, what's that become?
2 square root of
10 over 2 root 5. If you skip to this, I am okay with that. Just be careful. Make sure you're not writing 4 square roots of 5. But you don't have to write this step. If you're a person who tends to miss things, write that step. But I don't care if you go directly to this. Kate, what would you like me to do next?
Get rid of the square root.
How?
Times it by itself.
Do I have to multiply the 2 with, or is just the square root of 5 enough? Okay. The square root of 5 is enough. Here's why. Your goal is to get rid of the square root. Is multiplying this by a square root of 5 going to make the square root disappear? Yes. Now, if you multiplied by 2 square roots of 5 on both top and bottom, you're just making more work for yourself, but it's going to work out. As long as you multiply it correctly, it'll be fine. When there's no addition or subtraction, just multiply by whatever square root's in the denominator. 10 times the square root of 5? 10 square roots of 5. 2 square roots of 5 times the square root of 5? 2 square root of 25. By the way, technically there's a 1 in front of this getting multiplied by the 2. So there is technically the 2 getting multiplied by something. It's just not doing much. Okay. The next step, I did that to turn that into a 5. One of the most common mistakes I see is people do that. Be careful. What's between the 2 and the 5? Multiplication. If you don't write that as a multiply there, it just looks like 25. Okay, 10 square roots of 5 over 10. Can I simplify it? Yes. 10 over 10 turns into a 1. 1 square root of 5, also known as just square root of 5. Are there steps we could have skipped in this process? Absolutely. Am I going to write them all out in my notes? Absolutely. Okay. I'm going to change it up on you again. Do you notice a subtraction symbol showed up in that denominator? Makes a difference because in this situation, if I looked at this problem and said, okay, I want to get rid of the square root in the denominator, and I started multiplying by the square root of 3, I would have to remember something. Top, easy enough. Bottom. Technically, this is a fraction. It's a fraction that's the fancy version of, what is something divided by itself? 1. It's just a fancy version of 1. When I multiply fractions, if there's addition or subtraction, what do I need to make sure I do? Put it in parentheses, and therefore I need to distribute. Square root of 3 minus square root of 9. In other words, square root of 3 minus 3. Did I get the square root out of the denominator? No, I just moved it. I just made the problem more complicated. I have to approach it a different way. I have to approach it in multiplying by something that makes all of this essentially become perfect squares. Thoughts on what we can multiply by that makes things into perfect squares? Not quite. If I want two things to multiply together and become perfect squares, and one of them is a binomial, the other one has to be a binomial. So, I got this binomial. I don't know. We're just going to call that an A. We're going to call that a B. Just for the sake of ease of writing. I'm going to have to multiply it by another binomial. Such with that when I multiply it out and do that FOIL, what I want to happen is the square roots to cancel out. And if this has got a square root on it, when I multiply these things, multiplying it by itself is no problem. That's a perfect square. Multiplying it, okay. I'm not making this make sense. I'm going to take a step back and just say, okay, you want to get, when there's addition or subtraction in that denominator and you've got a square root, the thing you want to multiply by is the conjugate. The conjugate is the same thing except the middle sign. Instead of a minus sign, I'm going to change it to a plus sign. If it was a plus sign, I would want it to be a minus. In short, that's what you need. When you are trying to multiply by something to get rid of a square root in the denominator, if there's plus or minus, whoa, that is not even close to how you spell conjugate. Let's try this again. We will continue after lunch. So you got addition or subtraction in that denominator. You want to get rid of the square root. You multiply by the conjugate. The conjugate is that binomial where you change the middle sign. If it was plus, you change it to a minus. If it was minus, you change it to a plus. Keeping in mind, just as mentioned earlier, when you are multiplying by this, you are technically multiplying by a fraction. And therefore, you need parentheses. And you're going to have to distribute things out. Four times 1 is easy. 4 times square root of 3 is just as easy. One times 1 is 1. 1 times the positive square root of 3 is square root of 3. Negative square root of 3 times 1 is negative square root of 3. And negative square root of 3 times positive square root of 3 is negative square root of 9. Now there's still square roots down there, but those two are going to cancel out. They're always going to cancel out when you're multiplying conjugates. That's the reason we multiply by conjugates. Square root of 9 will simplify. Four plus 4 square roots of 3 all over 1 minus 3. Four plus 4 square roots of 3 all over negative 2. Now from here, if we can simplify further, we need to. Simplifying further when there is addition or subtraction is a little more complicated. In all technicality, if I want to simplify this fraction, I should be going through and I should be factoring out the things in the numerator if possible. Or, there's an easier way to do it. Look at all 3 whole numbers. And when I say 3, I mean 3. Sometimes you will have ones that look something like 2 plus square root of 5 over 4. There are still 3 whole numbers there. There's the 2, there's the 4, and what's the third one? The 1 hanging out in front of the square root of 5. Anyway, you look at the 3 whole numbers and ask, does something divide out of all 3 of them? It's 4, 4, and negative 2. What divides out of all 3 of them? 2. More accurately, we want to pull out a negative 2 because you also cannot leave negatives in the denominator. So, always look at all 3 of those. Keep in mind that it could be a 1. Divide that by a negative 2, I get negative 2. Divide that by a negative 2, I get negative 2. Still has the square root of 3. Technically over 1. Do we really need over 1? No. Okay, got one more simplifying radicals, and then we're going to change it up completely. Try this one out on your own. Okay. If I want to make this work, if I want to simplify this, Ella, what should I multiply by on top and bottom? 2 and the square root of negative 6. What's the sign in between them, though? Minus. I already did it up on screen, so that's why I'm doing it over here now. So yeah, 2 minus the square root of 6. If you do 2 plus the square root of 6, it's not going to do you any good. Negative 5 times 2. Negative 10. Negative 5 times a negative square root of 6. Be careful, negative times a negative. 2 times 2 is 4. 2 times negative square root of 6. Negative 2 root 6. Square root of 6 times 2. 2 root 6. Square root of 6 times negative square root of 6. Negative square root of 36. Do those two cancel? If they don't cancel, something's wrong. So I end up with negative 10 plus 5 square roots of 6 all over 4 minus 6, which just happens to be negative 2. Can I leave it like that? No, you can't leave the negative on the bottom. So when you're looking to simplify, make sure you're looking at all 3 of these numbers. They don't divide by really anything other than 1, but since this is negative, I'm going to divide them all by negative 1. 10 minus 5 square roots of 6 all over 2. Okay, so simplifying square roots, it's up here as well. Now shown. Simplifying square roots is one of the 2 big concepts that we needed to bring back for today. Other one, you initially learn it in middle school, comes back up in geometry. It's Pythagorean theorem. What is Pythagorean theorem? Does anyone remember? Say it a little louder. A squared plus b squared equals c squared. True, that is our theorem. But what is it for? What type of triangles? Right triangles. What does it help you find? Sometimes the hypotenuse. It's the missing side length. Specifically, it has to be right triangles to use this. It's not a right triangle, you can't use Pythagorean theorem. Now, when you're working with this, yes, it is a squared plus b squared equals c squared is the theorem. What are a, b, and c? Helps you find missing side lengths, so it would be logical that they are side lengths, right? Does it matter which one goes on which side? Yes and no. Which one do we have to be picky about, A, B, or C? C. C has to go on which side? In this case, it's the slanted, but it's not always the slanted. It is always the, what did I hear? Hypotenuse, or the longest side. The hypotenuse is always going to be the side across from the right angle. What are the other 2 sides called? What's with an L? You have 2 of them. Legs. A and B are the legs. It doesn't matter which leg goes into A, which leg goes into B, as long as the hypotenuse goes into C. You're going to find the exact length of the missing side. If you're going to do Pythagorean theorem, most important step is recognizing which side is the hypotenuse, because if you put it in the wrong spot, you're going to have issues. Olivia Mose, which side is the hypotenuse, the 3, the 6, or the x? It's across from that right angle. Okay. Lauren, what's Pythagorean theorem look like then with this triangle? Hypotenuse squared, c squared, x squared. Any of those work. Okay, 3 squared plus 6 squared equals x squared. One of the most common things that I see for some reason is people not solving this in the correct order. Because people say, okay, x is squared, I want to get rid of the squared, so I take the square root, so therefore it's 3 plus 6. No. Simplify before taking your square roots. 3 squared is? 9. 6 squared is? 36. Equal to x squared. Combine like terms. 45 is equal to x squared. To get rid of a squared, you take the square root. Now, in all technicality, when you introduce the square root to a problem, what are you supposed to introduce with it? Little symbol that goes in front of it. Plus or minus. Does that make sense for triangles? No, there will be plenty of times where we are using square roots in this trimester where you will need that. A triangle side length? Nah. Okay, if I want the exact answer, am I going to my calculator and typing in the square root of 45 right now? No, because it's not a perfect square. If it was a perfect square, then we would be just fine. Oh my goodness, words. Not just fine here. How do I get the exact answer for the square root of 45? I look for the two things that multiply together to get 45, one of which is perfect square. I heard square root of 9, square root of 5. Beautiful. Which simplifies to 3 square roots of 5. Just got 2 more examples. These 2 examples hit on something, or each hit on some common mistakes. Aubrey, which side's the hypotenuse? Good. Andrew, what does that mean Pythagorean theorem looks like?
2 square root of 3 squared plus y equals 39. Square root of 39 squared.
You are right that that is going to turn into 39. There's a reason I want to do this first. I also missed that something's missing.
Oh, y squared.
Technically, there's something else missing. Parentheses around what? 2 square roots of 3 better be in parentheses. Otherwise, the only thing you are squaring is the square root of 3. That's not the full side length. So you have to be careful of that. Because otherwise, if I try to do 2 square roots of 3 squared without the parentheses, it is going to tell me that it is 6. When the answer is actually, what is 2 square roots of 3 squared? Okay, first off, you could do it in a calculator. Second, you could just distribute that squared. What's 2 squared? 4. What's the square root of 3 squared? 3. Squaring a square root just leaves you what's inside. If you type it into your calculator, assuming you put parentheses where they belong, it would also just tell you that it was 12, which is what 4 times 3 is. As Andrew mentioned earlier, the square root of 39 squared is just 39. Subtract 12. 5 squared equals 27. To get rid of the squared, we take the square root. Do we need the plus and minus? Not for triangles. Y equals. What perfect square does 27 divide by? 9. Square root of 9, square root of 3. 3 root 3. Okay. Final example just shows one other thing that is seen. That's a 45-degree angle in there. This uses one other thing from geometry. Do you notice that I've only got one side length actually marked with a number? This one's missing. But I put an angle in there. Put an angle in there for a purpose. It's a 45-degree angle. If we look at this triangle, there is technically one other piece of information that is not marked on it that we should know. That's this angle. Because angles of a triangle add up to what? 180 degrees. That sound familiar? Now here's the thing. If they have to add up to 180, that means this angle's 45 degrees. Do you recognize that there are 2 congruent angles in this triangle? 2 angles that are the same? If there's 2 angles the same, that means there is also 2 sides that are the same. If these are congruent, these are congruent. That means this length is x. Luke, what side's my hypotenuse? Which side is the hypotenuse? 12. Which means my Pythagorean theorem is going to be x squared plus x squared is equal to 12 squared. Olivia, if I want to solve this, what do you think I should do? Lee? Beautiful. 144. What can I do with x squared plus x squared? Ethan. What is x squared plus x squared? 2x squared. It is not x to the fourth. Divide by 2. Y'all know what to do from here. X squared equals 72. And then you square root it. Square root of 72 we did already. It's the first problem we did. It's 36 and 2. Therefore, it's 6 squared root of 2.